Down to the weir, and we're just going to quickly change the water level. As you can see, the water is open flowing here. You can see a little piece of the weir board. In the summer the water flows over there, and I'll just go dig up the overflow pipe, which is, the location is marked by this stake here, and if you just dig a little bit in here, you will see that there is an overflow pipe here. Now I can actually, right now it's either plugged or it's not overflowing, which means we're probably using a little bit too much water with our hydro generator. And I check here, and the full hand length below the top. So we're apparently using too much water, so we have to turn down the needle valve down at the hydro to make sure that we have enough water in here. The intake is still quite a bit below, so we don't have to panic, but we should have flow through this pipe here, and we don't. So go turn down the power a bit. We're down at the hydro station now. The generator building is behind me. We noticed already that we don't have enough water right now, but we also don't have enough power, so we're trying to investigate what the problem is. Quite often what happens, we either get ice or debris buildup in the nozzle for the Pelton generator, or we have dirt in there as well. So we also find that we have some air in the line periodically. It seems to come in somewhere. So it's a good idea to shut down the generator once a week approximately to get all the air bubbles out. I'm going to do that today and shut down completely and then start it up again. What we do is there's actually a set of instructions posted in there, so anybody who's not familiar should go through those a couple times before they actually do it. We will disconnect the power on the main switch and then run down the turbine by closing the valve gradually until there's no more water flowing. Then we wait until the static pressure in the penstock line stabilizes to know that all the air is out, and then we will do a restart. The restart procedure is exactly the reverse of shutting it down. We will run up the RPM to over 60 Hertz, ideally 65, 70. Then we throw the power lever, the power starts loading the generator and it starts regulating itself. The mechanism to do that, the mechanical mechanism to re-engage or disengage the deflector actually that deflects the water while we're turning the power off, is a little complicated and involves a little solenoid that you have to kind of push up on it. There's a little lever that will hold the counterweight in place, and you'll see all that when I'm doing it, but it's very noisy there, so I better explain it now. I'll go through it very slowly while I'm in there. So the first thing, shut down the main switch. The regulator will shut down the generator by itself by engaging the deflector. Then we shut down all the valves. We work on the needle valve to make sure it's all cleaned out. So we open it all the way, close it all the way. We set it to where we want it to be, and then we restart. Safety. So what is important too, there is the generator is directly connected to the Pelton turbine, and there is a shaft that turns very fast, and the coupling between those two is exposed open, so it turns very fast. If anything gets caught in there, like a hand, a scarf or whatever, it's very, very dangerous. So you have to keep your hands off that thing while it's still running. Once it is shut down, you can actually work on it, but it has to be completely standing still before you start touching anything that's near the coupling between the generator and the Pelton turbine. So what I will do now, I will call the lodge and tell them that we're going to shut down the power in a few minutes and that it will be off for a few minutes. Purcell Lodge from Thomas. Yeah, Tony, we're about to go in there and shut down. So in a couple of minutes the power will go out, and then we'll probably be a few minutes until it comes back on. I'll let you know when that happens.
Okay, roger that. The power is right now at 4.4.
Okay, thank you.
Okay, maybe just run over everything again, like the parts.
Okay, you've seen that as soon as I threw the switch here, the controller engaged this solenoid, who let then drop this big weight that deflects the water off the turbine.
Right.
So there's the mechanism which we will explain when we turn it back on. That little lever there supports the counterweight, and when the solenoid lets go, it lets go of the lever.
So the solenoid, I'll just show it here. The solenoid holds that bar down when it's magnetized.
Right. As soon as there's power on the solenoid.
As soon as the magnet drops, the bar flips up, the weight drops.
Okay. Now I've noticed the normal pressure on this is about 170 psi, and it was actually only 155, and it was fluctuating while it was running, which is telling me there's probably air in the system, but we're not quite sure. We have to see what happens, because I just turned off all the water, so we should get to a static pressure now. And the static pressure should be somewhere around 178. It's right now at 173 and still fluctuating. So that means there's something still in the line happening. I've just turned off the needle valve, and it felt there was no obstruction in there. So I'm pretty sure that there's no dirt or ice in there. It felt pretty easy to turn. When there is dirt in there, you can feel it crunch. And so you're just crunching it a bit, letting go again, crunching it a little bit until everything feels smooth to open and close the needle valve. So I will now go and open the needle valve to a setting that is slightly lower than we have before, because we were using too much water. And I have to count the turns I'm opening it, and we're recording that. There's a table that shows you what power should come for how many turns of needle valve. So I will do that in a minute, but we will wait now until the pressure stabilizes.
Okay.
So every 3 months, the bearings of the Pelton turbine need to be re-greased. And we're going to do that now. It's due. It has been 3 months. And we're going to do this by first finding the right nipple. So it's just these two bearings on either side of the Pelton turbine. So we're cleaning off this. I hope we have enough grease in the grease gun, which should always be ready. And then there's the other grease nipple on the other side, which would be there. So we clean that one off. There. And I think this goes on like that. Okay, and then I pump and see what happens.
Should be resistance.
There is resistance.
5 squirts is probably good enough. Okay.
And on the other side.
Yeah. Mention that as long as there's resistance, you know that there's grease in
I
the
feel resistance, cartridge. And I can also, of course, test it by pulling it off and see if I can squirt some grease out.
Yeah, okay.
And I can.
Okay.
There it is now. So that's done.
Okay.
You may want to bring a Kleenex or paper towel to clean off your hands. I use gloves, so now I have grease on my gloves and nothing on my hands, which works too. So we always want to record what we did on this maintenance schedule. And it's always on the wall here. So everything is the restarts are here. The last time it was greased, here says grease turbine bearing, October 1st. So I'm going to make a tick mark here and say, check, today is January 12th. And so that's already good enough. We will also say that we restart, and we will record the openings, how many turns the needle valve is open, and what the pressure is. But we're still waiting for the pressure to stabilize, which it has done at 178. That's our normal static pressure. So what I will probably do, since we didn't have quite enough water, I will open this to 4.5. We were at 4 3/4 turns open. We'll probably go to 4.5 or 4 1/4. I have to decide that yet, and then go check the weir again. We'll probably go with 4.5 for now, and then we restart the whole thing and see what the dynamic pressure is after it's restarted. So I'm going to write down here. It was at 155. Then we go to 168 static. Then I say restart. And then I will record what the pressure is once it's running. Tuck that away in a safe place, because we don't want anything to get caught in the coupling in here while it's running. This green thing is the dangerous part that's moving. Okay, so what I'm going to do now, I only closed the needle valve, so I'm going to open it all the way to make sure that if there's any debris left, it'll go through. I'll open it all the way, I'll close it all the way again. Then I will open it to 4.5 turns. Then we're done with this part, and I'm going to go start the generator again at the main panel over there. So I'm opening it. You will hear water running now because it's going through the deflector as I open the valve. And it's 7.7 turns all the way open, so that's a while. It's got to take a while. This is starting to turn. Watch it. Okay, all is quiet. The piece of tape as a marker is pointing straight up. So now I'm going to count 4.5 turns open from there. It'll get noisy again, the water will flow again. So we go. 1, 2, 3, 4, and all the way to the bottom, 4.5 turns. You got the water flowing a lot. You can also look at the pressure that's dropping a little bit. It's still stable pressure. So we're good. It should drop a bit because it's now dynamic pressure, not static anymore. This is a bit complicated because that lever holds the weight and it's held in by this solenoid. So when that's up, this is firm. So what you have to do, we usually tape this a bit, pull the lever up, let this drop, push this up. Now, I'm gonna pull this up. It will go up to over 60. As soon as it's over 60, I pull the main switch and I pull it up. So, lift, watch, switch. Now we're going to check back with the lodge if we have stable power again in terms of how many kilowatts we pull out. Purcell Lodge from Thomas.
Purcell Lodge here, go ahead.
Are you anywhere near the meter so you could tell me how many kilowatts we have?
That we're 4.9 kilowatts right now.
Thank you very much. That's perfect. We're on 4.5 turns, 4.9 kilowatts.
Excellent. Thanks.
And that's it. So a reminder, don't forget to record the running pressure. I noticed it was 171 psi. You'll throw another look there. You didn't lose any gloves in there. You didn't leave anything. And make sure all the tools are back where they belong. And the sheet is back where it belongs in the wall. And then we close up, we make sure that everything's nicely closed. When we have a big snowstorm, we don't want the door to blow open. That would not be very good. And we're all good.
Okay.